Hi, hello all. Good morning, good evening. This is Rakesh Jaiswal once again, and today topic is Microsoft Azure Service Fabric, which is very good product from the Microsoft, and it's pretty prominent, and it's popular in Microsoft Azure. So this is introductory, and I will be walking through about what is it all about, and I will be covering some aspect of microservices as well. So without any delay, let's get started. And today agenda will be just to uh, application composed of microservices means I will be giving a high level walkthrough of applications which are composed of microservices, container deployment and orchestration, any OS, any cloud, stateless and stateful microservices for service fabric, application lifecycle management and summary. So, yeah. So, overview of Azure Service Fabric. Azure Service Fabric is a distributed system platform that makes it easy to package, deploy, and manage scalable and reliable microservices and containers. Service Fabric also address the significant challenges in the development, like managing cloud native applications, right? Uh, Developers and administration can avoid complex infrastructure problems and focus on implementing mission critical, demanding workloads that are scalable, reliable, and manageable. So that's where most of the focus would be, where a developer would be focusing on developing the business logic instead of worry about the infrastructure, platform, and cross-cutting uh, concerns. So all this will be taken care by Service Fabric itself. So Service Fabric represents the next generation platform for building and managing these enterprise class tier one cloud scale and application that runs in containers. So these are the key usage of Service Azure Fabric. So, application composed of microservices. So, as you will be seeing this graph, right? So, how we can develop a application which is composed of microservices. So, I will not go in more depth about microservices here. Just I'm giving high level architecture as a client application, right? It will be interacting with uh, API gateway, and API gateway will be front facing for our microservices, and microservices will get deployed in a microservices fashion in any platform which can support microservices. Either we can build our own Docker containers, or we can use any platform like cloud, ECS, or Amazon. That's the overall application architecture, how it will be getting deployed through alpha of Service Fabric. We will be diving in. So, Service Fabric enables you to build and manage a scalable and reliable application composed of microservices. So those microservices that runs at high density on shared pool of machines means these microservices will be running on uh, uh, high density means more than one instance of a particular microservice would be running in the infrastructure. So that kind of capabilities Azure Service Fabric provides. So and Azure Service provides a sophisticated lightweight runtime to build a distributed, scalable, stateless, and stateful microservices running in containers. And it also provides comprehensive application management capabilities to provision, deploy, monitor, upgrade, or patch, and delete deployed application, including containerized services. So, Service Fabric powers many Microsoft services today. It's a very powerful tool. Even Microsoft itself uses for their uh, bigger services, including Azure SQL database, Azure Cosmos DB, Cortana, Microsoft Power BI, Microsoft Intune, Azure Event Hub, Azure IoT Hub, Dynamics 365, Sky for Business, and many core Azure services are running into uh, running containerized environment, which has been powered by Service Fabric. So Service Fabric is tailored to create a cloud native services that can start small as needed and grow massively, uh, with hundreds or thousands of machines. So, if you are developing application which are microservices, based on microservices, there Azure Fabric will be more helpful to deploy, manage your services. For example, nowadays inter-scale services are built of microservices. For example, of microservices include the protocol gateway, right? And either user profile, you are trying to develop any microservice, or you are developing services for shopping carts. So these individual services, shopping carts, inventory processing, so these services will not be able to sustain by hosting but just a couple of machines or couple of instances. It should be elastic. It should scaling as per the demands, right? So, a Service Fabric is a microservice platform that gives every microservices or container a unique name that can be either stateless or stateful. So, Fabric provides comprehensive runtime and life cycle management capabilities to applications that are composed of these microservices. And it has microservices inside the containers that are deployed and activated across the Service Fabric cluster, right? So, if uh, it is a move from virtual machine to containers, right? That make possible, and the order of magnitude increases in intensity, right? So that kind of uh, beauty you can get here. Similarly, another order of magnitude in the industries becomes possible when you move from containers to microservices in these containers. So again, from containers to microservices containers. So that's the kind of philosophy. Like you are having virtual machines. In that virtual machines, you can run n number of microservices through help of containers. So, for example, take example of Azure SQL database that comprises hundred of machines that runs 10 of thousand of containers that house a total of hundreds of thousands of databases. And each databases is a service fabric stateful microservice. So that's the uh, applications you can compose with the microservices, and where you can use the service fabric. So container deployment and orchestration. This is the one of the biggest feature of Azure Service Fabric. So Service Fabric, as we know, it's Microsoft Container Orchestrator, right? It's nothing but it's container orchestrator, which deploys microservices across the cluster of machines. And microservices can be deployed in many ways, from using Service Fabric, programming model, or ASP.NET Core, uh, to deploying any code of your choice. It doesn't matter what kind of code you're deploying. And importantly, you can mix both services in process and services in containers in the same application. Means you can run more than one instances of different services in one container, which will composed for a particular application. And if you just want to deploy and manage containers, Service Fabric is perfect choice as a container orchestrator. Just in that way, you can also use it. And it's fault isolation, healing, secure upgrades, scaling up and down. All this it will take care. So we will be discussing about a stateless application and a stateful application. A stateless application that is nothing to disk, and there will be web front end, can stop and start as many containers as you like. Containers is a ephemeral, right? So it will comes up and go down. No container instance is specific configuration uh, will be it will be crossed container uh, configuration. Stateful application in stateful containers is specific host name IP address will be there, and big data services configuration information, security secrets, password, and KDC keys to maintain a state of the application. In these scenarios, we will be using stateful. Application composed of microservices. So, uh, we- yeah, so this is another explanation of application which can be composed with the microservices in monolithic application approach, right? We were building one application, and we were having uh, all services bundled with together. And in the second step, in the deployment, we were having machines in our data centers, and we were deploying all these services together into two or three instances, and we were doing the load balancing on top of it. But in microservice application approach, um, we uh, for example, this is a scenario for one application. But in case of application 1 and application 2, which are composed of three different microservices, and if we want to deploy these microservices, just we will span VMs, and on top of VMs, through help of any Azure Service Fabric, which will uh, uh, construct a logical cluster of these machines, and it will deploy all microservices into different nodes, and it will try to make sure that
and these services will get replicated across the node based on their replication factor, and it will make sure that more than one instances are running across the cluster in different nodes. So that's the another compositions of another way of displaying or explaining the composition of microservices. Let's move. Yeah, any OS and any cloud. So this is the one of the best feature of service fabric. uh, we can deploy it with any OS and any cloud as well. So, for example, if I want to explore or manage in my dev machine, I can install into my laptop or development machine. I can utilize it. Either it is Mac or Windows, it doesn't matter, or Linux, and uh, and it also comes uh, on cloud as well. So in Azure, we can utilize Service Fabric, and in on-premise data center also we can have our we can build a cluster, and over there we can deploy Service Fabric, and you can we can utilize as a orchestrator. And in another cloud also, for example, Amazon and Google Cloud, we can deploy over there as well. Yeah. So uh, Service Fabric, as we know, right, runs everywhere. So you can create a cluster of Service Fabric in many environments, including Azure, on premises, on Windows Server or Linux. Uh, I'm not sure about Mac. I think we don't support Mac. I will take my word back. Uh, and you can even create cluster on other public clouds as well. And in addition, the development environment i- is provided with the SDK, and that SDK is identical to production environment, uh, where we will not be having any emulators involved in production. But in our development, we can there will be SDK for emulation, where we can emulate it, and you can m- uh, create a virtual machines, clusters, and you can deploy your application, so that you will have a feel of running different nodes in your local, and even you can scale out, scale in also. So that's the overall feature in uh, for the any OS and any cloud. For Windows development, the SDK, the Service Fabric .NET SDK is integrated with Visual Studio and PowerShell also. For Linux development, the Service Fabric Java SDK is integrated with Eclipse. Okay, and from there, there is a human tool which is used to generate templates for Java and .NET Core and container applications. So we can use the SDKs to uh, emulate or in production to create a template for cluster management. All right, so let's move. Yeah, It supports stateless microservices for service fabric, right? So stateless, stateful, these are the two way to develop microservices. I will uh, develop. I will deliver another videos which will be focusing more on microservices. Uh, but here, Service Fabric enables you to build applications that consist of microservices or containers, right? And a stateless microservices such as protocol gateway and web proxies, where we don't need any state. Uh, so, stateless microservices do not maintain immutable state outside a request and its response from the service. So, for each request and response, it doesn't maintain any state or outside of its process, including request and response for one service call. And is your cloud service worker roles are an example of a stateless service. So stateful, that is the stateless service. Another benefit of as this graph depicts, right? We are having websites, and websites are consuming services, uh, and those services are instances of same service. For this example, and they're making calls through help of service. Suppose if we want more reliable calls, right? So in that case, we will be using uh, any messaging broker system. So in that scenarios, we will be using queues, and in queues we will be putting our messages, and these services will be uh, polling those queues and performing the business logic, and again they can put back into another queue, and from there another service can consume it. And in stateless, there will be storage which is outside of the service compute boundary, and and if we want to increase the performance, we can use cache in between. So, for example, these are the front end, this website of front end websites which are stateless, and stateless middle tier compute are there. So, what is the benefit of stateless or characteristics? So, its characteristics is scale with partitioned storage. So, these storage are partitioned storage for individual services, and increased reliability with queue. If we are leveraging queue, through that we can increase the reliability, reduce the read latency with caches. So we can introduce cache to reduce the latency. Uh, Write your own lock manager for state consistency. So if we want to maintain state consistency, then we have to write our own lock into the compute itself to maintain the consistency. And many moving parts, each managed differently. So here you are seeing for some of the services we can introduce cache, for some of the service call we can leverage queues based on its nature of compute, right? What kind of service it is. So we need to think about a lot of cross cutting concerns here. Okay. So next is stateful microservices for service fabric. So here in stateful, right? So in stateful microservices such as user account, database, device, shopping carts, and queues. Uh, all these maintain a mutable and authoritative state beyond the request, right? So out of the request response, it's maintained the state. So today's internet scale application consists of a combination of stateless and stateful microservices. So in this uh, stateful microservices, the services will be maintaining a state in form of small stories, right? So they will be having, each services will be having its own storage bag with it, and there will be another outside of all these services, there will be another storage which will be used for analytics and discovery and recovery purposes. So application states lives in compute tier. Through help of this, there will be low latency reads and writes. Partitions are first class for scale out. So these partitions, whenever we are partitioning the services into microservices, we need to think that individual services will scale out. So there should not, means one instance of a service will scale out with its own storage, where they will be maintaining the state of that service. And built-in log managers based on primary election, uh, uh, we will be looking into in service microservices architecture, how it works. And in these scenarios, there is a very fewer moving parts. Okay, so let's move on to application lifecycle management. So, as we know, right, application lifecycle management, we plan, develop, test, and then deploy and maintain. So, uh, Azure Service Fabric provides all these facilities. So, for example, if we want to deploy any application which is composed of microservices, we need to plan ahead. It might be one of the service will be getting utilized more often compared to other. For example, user profile will get utilized way less, and product detail or inventory services will be getting browsed more often. So we have to plan what should be the replication factor for a particular service, and also we will be planning for our cluster as well. So this is the planning for even we will be doing different planning for development and lower environment for testing and production. So all those planning phase we will be doing, and we will be developing those services. And in the lower environment, in dev environment, we will test it and then we will deploy. So it covers all aspects of application lifecycle. Even you can do the management, service management, testing, and uh, investigation. So yeah. So as we know, Service Fabric provides support for the full application lifecycle and CI/CD of cloud application, including containers. So this lifecycle includes development through deployment, daily management, and maintenance to evaluate decomposition, right? So daily you can perform daily management and maintenance tasks. So and based on that, right, you can decouple your services, or you can plan your deployment or scaling out or scaling in strategies. Um, And Service Fabric application lifecycle management capabilities enables application administrator and IT operators to use simple, low touch workflow to provision, right? And deploy, patch, monitor applications. So all these capabilities you will be getting out of box. And these built-in workflows greatly reduce the burden on IT operators to keep applications continuously available. Most applications consist of a combination of stateless and stateful microservices and containers, right? And other executable that are deployed together. By having strong types on the applications, Service Fabric enables the deployment of multiple application instances. Each instance is managed and upgraded independently, right? We will be seeing in more detail in microservices. And importantly, Service Fabric can deploy containers or any executable and make them reliable throughout its life cycle. So, for example, Service Fabric can deploy .NET, ASP.NET Core, Node.js, Windows containers, Linux containers, Java virtual machines, scripts, Angular, or literally anything that makes up your application. A Service Fabric is integrated with CI/CD tool such as Visual Studio Team Services, Jenkins, and Octopus Deploy, and can be used with any other popular CI/CD tool as well. So that is the more about application lifecycle management. So yeah, in this introductory, I would like to uh, give the key capabilities of like if I will be summarizing here. So key capabilities, application deployment services, we have seen rolling update with rollback, strong versioning you can achieve, side by side support you can achieve, you can run different versions of same services. And it provides a name service for discovery of application uh, and high density microservices you can achieve, load balancing and placement constraints. Um, so you can do Azure Service Fabric will take care of it, and it will also provide a consistent state replication framework and reliable distributed key value store collections and queues. So these are the capabilities, and apart from that, by using Service Fabric, we can deploy to Azure or to an on-premise data centers that runs Windows or Linux with zero code change. Write once and deploy anywhere to any Service Fabric cluster. That's the beauty. And you can develop scalable applications that are composed of microservices by using service fabric programming models, containers, or any code. Uh, and you can develop highly reliable stateless and stateful microservices. Simplify the design of your application by using stateful microservices. So that's the one approach you can take it, and you can use the novel reliable actors programming model to create a code, create cloud objects with self-contained code and state, right? And you can deploy and orchestrate container that include Windows containers and Linux container. Service Fabric is a data aware stateful container orchestrator. You can deploy application in seconds. That's the one of the beauty, at high density with hundreds or thousands of applications or containers per minute. You can deploy different versions of same application side by side, as we discussed, and upgrade each application independently. Manage lifecycle of your application, we have seen without any downtime, including breaking and non-breaking upgrade. You scale out or scale in number of nodes in a cluster. As you scale nodes, your application automatically scales. So just you have to configure scalability, monitor and diagnose the health of your application, and uh, set policies for performing automatic repairs. So you can set policies also. What's the resource balancer? There is a resource balancer. We will discuss in more detail. Orchestrate the redistribution of application across the cluster. So you can watch it resource to help of resource balancer, and you can perform the redistribution of application across the cluster. Service fabric recovers from failures and optimizes the distribution of load based on available resources. So that these are the key benefits or key capabilities. Um, uh, yeah, so that's all for today. I will be more diving into more architectural things in next session. Thank you all.